So this is our first problem. It's going to be very, very basic. It's a pretty famous problem when doing equilibrium of a particle type questions. And let's get right into it. So this question says, find the tension in cables CA and CB. Well, we're also given that this cable CA, because we're going to be looking at this particle C right here, this cable CA is at a 30-degree angle with the x-axis. And then we're given that CB is at a 40-degree angle with the x-axis. We are also given that the weight of this box, we're given the mass of the box as m is equal to 10 kilograms. Now, if you look back to the first video on this that I made, it says to start with a free body diagram, and that's exactly what we're going to do. So let's start with a free body diagram. So we have our cable C, or our particle C, and we have a cable CB, and I'm going to call this F of CB, so the force of CB, and then another cable going this way, we'll call that FCA, and these are at angles 30 degrees and 40 degrees with the x-axis. We also have a box here. Now, the force that this box is putting on C, our particle, is called the weight force. And we went over how to calculate the weight force in the first video. We said that the weight is equal to the mass times the gravitational constant. And the mass is given as 10 kilograms. So we have 10. And then our gravitational constant is 9.81. So this is going to equal to 98.1 kilograms. Sorry, that would be newtons. We're dealing with a force here. Newtons. So that, and we remember that the weight force, it always acts downwards from the object in question. And that object in question is this box here. So we have 98.1 newtons downwards. So now that we have our free body diagram, the next step is to break up our forces into their respective components. And what we're going to see here is that our FCA has a component in the y direction, and it also has a component in the x direction, as well as CB here has a component in the x direction and a component in the y direction. So let's get right into it. As you can see on the left here, we have our free body diagram. I'm going to isolate FCA. So looking at FCA, we see that it has a y component and an x component, and it is at an angle of 30 degrees with the x-axis. So to the components for FCA are, we have the y component here, which is FCA sine of 30 degrees, and then our x component, which is FCA cos of 30 degrees. If you're stuck on the trig, please consult, or please go watch my my trig review video. It's very quick and it'll get you up to speed. So next, we're going to isolate FCB. Now let's not forget what we're trying to do in this problem. If we scroll back up here, we want to find the tension in the cables CA and CB. So we have FCA and FCB. So as we know, this has an x component, this has a y component, and it's at an angle of 40 degrees. So its y component is FCB times the sine of 40 degrees. Its x component is FCB times the cos of 40 degrees. So now we're on to step 3, which is to create our equilibrium equations. So we'll call those EE. And that just means we're going to take the sum of the forces in the x direction and the sum of the forces in the y direction. And as we know, we're doing an equilibrium problem, so the sum of the forces in each direction are going to add up to 0. So using our free body diagram and our components from step 2, we're going to say the sum in the x directions, the sum of f of x is equal to 0. We're going to specify a direction for positive forces, so we're going to say to the right is positive. And we're just going to add up all our x components. So if we look at our free body diagram, we have FCA, FCB, and then our weight force. Well, our weight force is just solely in the y direction, so we don't need to worry about that. But FCA and FCB both carry x components. So on to step 2. Let's start with FCA. FCA has one x component, and that's going to be FCA cos of 30 degrees. And remember, we decided that our positive direction is to the right, and this component, f of x, for FCA is going to the left, so this is going to be negative. Now, does it have any more x components? No, so we move on to FCB. FCB has a positive x component called FCB cos of 40 degrees. Next, we're on to the y components. And we're going to say that upwards is positive. So the sum of f of y is equal to 0. So let's consult our free body diagram. We have y components for FCA, y components for FCB, and then we have this negative y component for the weight force. And that's negative 98.1. Let's go to step 2. Our y component for FCA is positive FCA times sine 30 degrees. And our y component for FCB is positive FCB times the sine of 40 degrees. Now, remember, what are we actually trying to do in this problem? And that's to find the tension in cables CB and CA, right? CA and CB. And that is FCA and FCB. So we're going to have to solve for these values. So as we can see, we have two equations. We have equation 1 right here and equation 2 right here. And there's two unknowns in these equations. We don't know FCA and we don't know FCB. So performing a system of equations, we can find that FCA is equal to 79.9 and FCB is equal to 90.4 newtons. And we're going to conclude that the tension in cables CA is 79.9 newtons and the tension in cable CB is equal to 90.4 newtons. So I just want to end off with a quick summary of what we learned today. So we always need to start with a free body diagram. And from that free body diagram, we go on to components and we separate our forces into x and y components. Next, we use the equilibrium equations and set the sum of f of x is equal to 0, and we set the sum of f of y equal to 0. Then we add up all of our x forces, and we add up all of our y forces, and then we solve for the respective variables. My next video is going to cover a much harder example, and I'm going to go more in depth in that one. Thank you for watching again. Make sure to subscribe if you liked the content. Give me any criticisms that you have, like be as harsh as possible because I'm just starting this out and I'm learning. And now I would really appreciate if you just tore apart this video so my next couple could be a lot better. Again, thank you for watching. Have a great rest of your day.